Hello guys. So today we are here to discuss about Google Bigtable. So what is Google Bigtable? To understand the point what Google Bigtable is, we need to see more type of things out there to start with Google Scale. So what basically Google Scale is? There is lot of data, right? In the web we have copies of the web, satellite data, user data, email in Usenet, subversion of baking store, sorry. So in the Google there are many incoming requests at a time, right? Due to that the system lagged performance and efficiency at that time. So the commercial system was not big enough so that it could have afford things out of that scale which Google was experiencing at the time. So what uh, what the building blocks of Google Bigtable was Google file system and Chubby log service. And let's talk about Google file system first. uh, Google file system is a large scale distributed file system, and it is responsible for all the metadata of stuff. Where are the chunk servers is the sole responsible for reading and writing large chunks of data. Chunks will get to know is the mm, quantum from which we can read and write data, like in a continuous manner, and each chunk is identical to another chunk in the terms of size, right? So chunks are replicated on three machines, and the master is responsible for ensuring that replicas of each chunks exist so that the load can be defactored upon the replicas, right? So what Chubby is? Chubby, let we get back to Chubby. It's a coarse grained logs can store small amount of data in a log, and five replicas are needed uh, for a majority vote to be active, right? Which also was an OSDI 6 paper. So a big map is this, like this is how we can support things out there. This is the SS table. It's kind of you can pause over it and see how the chunks were there, right? Immutable sorted files of key value pairs where the data can be indexed in block ranges, not the values. These chunks, when are seen on a broader level, can be distributed into tablets. So what tablets are? Tablets are basically the containments of same range of rows of the table built out of multiple SS tables. So basically SS table, as we saw, was 64 kilobytes block. It was a table consisting of 64 kilobytes blocks with an index at the starting, and uh, that works as a quanta for the tablets. Now we comes to the table, the Google table which we are here talking about. This was kind of prerequisite which we needed to know in terms of understanding the Google table. So multiple tablets which we saw, consisting of all the blocks, are required to make up the table, where SS tables can be shared and the tablets do not overlap. That's the main part of it, because they are all independent kind of quantums out there. They don't overlap each other, and SS tables can overlap because SS tables are not independent kind of stuff, right? um, we can also deduce that tablets are a key value pair type kind of stuff, where the table IDs and end rows acts as keys, whereas the of data to that key is the location of the other tablets, right? Cache read client sites which may detect data to be incorrect, in which case lookup on hierarchy is performed. Okay. um, it is also prefaced for range queries and cached at the client side, so that the data retrieval can be uh, fast, right? Now let's talk about the servers serving the tablets. Tablet servers manage tablets where multiple tablets per server exist. Also, uh, each tablet is around 100 to 200 MB depending upon the individuality of the tablets existing, right? Each tablets live only one server, right? When we are talking about tablets, so since we have talked that it is an individual unit, so each tablet lives at only one server. Tablet server splits tablets that get too big, okay? So what tablet servers do is, like, if at all a tablet tends to move to more than the enough size, so the servers basically splits the tablets that gets too big in size, right? Also, the master is responsible for load balancing at the fault tolerance. So whenever the uh, load is much enough so that the individual tablets can't hold it, so load balancer is a role which is assigned to master. And of course, in the case of any fault if arises, then master have the authority and the ability to handle it, okay? So as we saw, master's task is to use Chubby to monitor health of the tablet servers, whereas restart the failed servers is also the restarting of the failed servers is also kind of uh, digged up into the master's task. However, tablet servers registers itself by getting a lock in the specific directory, which is called Chubby. Chubby gives lease on the lock that must be renewed periodically. Servers loses locks if it gets disconnected. Masters monitors this directly to find which servers are alive. And if the servers are not contactable or has lost the lock, master grabs the lock and reassigns the tablets. GFS replicates the data, prefer to start tablet server on the same machine that the data is already at. So as we saw, master's task is pretty much over there. However, some more bits can be added here in the terms of task when we talk about the tablets, the tablet management. So it have the master lock on Chubby, finds live server, communicates with server to find the assigned tablets, etc. Also, it scans the metadata to find all the tablets. As we saw, these are the independent units, so we need to scan all the tablets synchronously so that to have them in the same position. Metadata management is something which is master's task at the end of the day, as master handles table creation, merging of the tablets, etc. Tablet servers are directly updated on metadata split, and the masters are notified about this action. How you can edit a table. So mutations are logged, then applied to an in-memory mem table, so that the deletions are entirely handled by the updates. Group commits on log collect multiple updates before the log is get flushed. Okay, compactions. So minor compactions are there uh, to convert the mem table into the ss table. We need to reduce memory usage, we need to reduce the log traffic after the restart. Merging compaction, reducing number of ss tables, good place to apply policy. Keep only n versions. N versions in here signifies a thing which can be reduced to a specific number of versions, where we can quantify the number of versions, okay? Major compaction, merging compaction, uh, that results only in one ss table where no deletion of records, only live data is there. Locality groups columns family together into an ss table, avoiding mingling data, page contents and page metadata. Can keep some groups all in a memory, but we need to keep it all sorted to have stuff all around the tablet movements. Log handling are also kind of stuff which are appreciated at the time of tablets creation, as Google tables need to be handled that way only. Immutability is a kind of very nice feature in the terms of SS table, as it simplifies the caching, sharing across GFSs, and garbage collection of SS tables is also done by master. So immutability is kind of a thing which is a stuff. Also, micro benchmarks are there, like of tablet servers. Here are the uh, benchmarks which we can refer to. You can pause the screen and see them. So, lesson learned. Interesting point. Only implement some of the requirements, since the last is probably not needed. Many types of failures are possible in the terms of SS tables and Google tables tablet. Big systems need proper system level monitoring and values simple design. Okay. Thank you for your time. Let's learn more topics in upcoming days. Thank you. All the credits to Professor Anurag Punde to for making this video possible. Thank you, sir.